Okay, this is question 8 from the IA2 Specialist Mathematics paper. Use proof by mathematical induction to prove that 3 to the power of 2n plus 4 minus 2 to the power of 2n is divisible by 5 for all numbers that contain elements of real numbers. So, for me personally, in an exam, if I see this question, this is probably the first question I go to, purely because it is so easy to get at least 4 of the marks by pretty much doing nothing. It's just substituting k's and 1's into the equation. So there's 3 main steps you need to know with a question like this. It's been tested in multiple choice of your knowledge with the steps. So we have our first step, which is our base step, our second step, which is our induction step, and our third step, which is our conclusive step. So what we'll do is we will rewrite this equation that we have, and we'll start at plus 4 minus 2 to the power divisible by 5. This line just means divisible by. So that is our question. Now we'll start with the first step. Very easy marks, our base step. So this is where we let n equals 1. We always have to write this, same with the each other step. So let n equal 1. We'll sub this in. And divisible by 5. We'll then solve this, so that's 3 to the power of 6 minus 2 to the power of 2 is divisible by 5. This will end up as 729 minus 4 is divisible by 5, which is then 725 divisible by 5. Now if we have a look, 725 divisible by 5, that ends up being 145. So therefore, we'll always have to write these statements, therefore true for n equals 1. Now because we've seen that it's true, we can continue with our induction process. But if this was not true, that means that our n wouldn't work. Sometimes you'll find that you'll probably have to change the n to a different number, or simply the equation just doesn't work. The left-hand side will not equal the right-hand side. So we're on to our second step. This is called the induction step. So this is where we let n equals k. This is, again, super easy to get marks. So we'll sub in k where n used to be. So that's k plus 4 plus 2 to the power of 2k equals 5m. Now, why we write 5m, you say? Well, this step is our assumption step. So we'll use this step for our third one, our conclusive step. This m here, that can be assigned with any variable. I tend to have an m. It's just what I do. But the second step and third step, I always keep as the same variables, just because you don't want a lot of different variables, and it'll just get too confusing. So here we've assumed that the left-hand side equals the right-hand side, blah 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 blah. So this is all we have to do for our second step. So therefore, assume true for n equals k. A mark, done. That's literally how easy it is to get marks in this question. Now, our third step, our conclusive step. This is where we let n equal k plus 1. Okay, so we'll sub this in. 3 to the power of 2, k plus 1 plus 4, 2 to the power of 2k equals 5m. Again, I write 5m. You can write 5p, 5a, 5z, 5 supercalifragilistic, but it doesn't matter. I always choose to have the same one as the second step. So what we'll do is we'll open up these brackets. So we've got 3 to the power of 2k plus 2 plus 4 minus 2 to the power of 2k plus 2 equals 5m. Now this is where I said before that the second step is mandatory for the third step, purely because what we'll do is we're going to rearrange this equation and then substitute it into this one. So what we can do is, again, this is a little bit of a, you really have to notice the patterns. So what we can do is we can rearrange this to go 3 to the power of 2k plus 4 equals 5m plus 2 to the power of 2k. And as you can see down here, we've got a 3 to the power of 2k plus 4. So what we can do is we can write 5m plus 2 to the power of 2k. And then we've got a 3 to the power of 2 remaining. So that times us. So what we can do is we can actually rub that out. We can just write 9 and then 2 to the power of 2k. And what we'll do here is we'll do the same. 2 to the power of 2 equals 5m. That's indices rules. That should be basic knowledge. So what we can see here is that we've got a lot of things timesing by 2 to the power of 2k. Again, that's one of these little patterns that you need to know. So we'll open up this bracket, 45m. That's obviously 9 times 5m. And what we can do is we've got a 9 times 2 to the power of 2k, and we've got a 4 to the power of 2k, or negative 2 to the power of 2k, sorry. So what we can do is write 2 to the power of 2k out here, and we can factorize it and write 9. And because we've got a minus, we'll write minus 4. Don't forget the 2 squared, equals 5m. We'll then simplify that bracket. Now we're nearly finished because this is a recognition type of thing. You can see that 45 is divisible by 5. We've got a number here that's timesing by 5. And here we've got something, again, timesing by 5. So we obviously want to find out that the left-hand side, back up here, that one is divisible by 5. So what we can do is we can pull the 5 at the front. 9m plus 2 to the power of 2k is equal to 5. Just to help you, we'll put an m in the bracket. Now, as we can see, if we, by putting out a 5 and factorizing the equation, we can see that the left-hand side is equal to the right-hand side, and the equation that 3 to the power of 2n plus 4 minus 2 to the power of 2n is certainly divisible by 5. So we write our little concluding statement for our conclusive statement. True for n equals k plus 1. So that's about it. But we're not completely finished. So what we get is we get marks for this step, we get marks for this step, we get marks for this step, but we get, so that's about 5 marks. I'd say probably 1 mark there. You'd have to look at the criteria, but I'd say 1 mark. Oh, why is it not working? 1 mark there, 3 marks there, 1 mark there. If that wants to draw. And then our last step, because it's a 6-mark question, is our concluding statement. So I usually write, I usually have one pre-planned. So I go, therefore, our original statement, 2n plus 4 minus 2 to the power of 2n is divisible by 5 as, and now we want to just restate our steps. So as n equals 1 is true, and we want to go to our third step, as n equals k plus 1 is true, assuming that n equals k is true. Now, this part may be a little bit confusing, but what we've done is because we assume that this is true, and then we substituted it into something that we do know is true, we have found out that n equals k plus 1. So, if n equals k plus 1 is true, that means n equals k has to be true. So we'll do that, finish our sentence, is true by proof, by induction, proof for induction, proof by mathematical induction, doesn't matter how you write it, it's synonymous. So that's it. That's the whole thing. So a lot of key points that you need to remember. Very easy marks. Let n equals k. Let n equal 1. Let n equal k. Let n equal k plus 1. Don't forget your statement, and remember the 3 steps: your base step, your induction step, and your conclusive step. Like I said before, there were multiple choice questions last year that did require you to. That made you. They gave you a step, and you had to pretty much pick one of the multiple choice answers and say what step it is. But yeah, that's it.